Recording in progress.
In last class we have discussed about VBT. Valence band theory, in which first of all we have discussed about who discovered this one. This is the scientist named Linus Pauling that got a Nobel Prize in 1954, in which he explained about the bonding in an molecule, in covalent bonding, we can say. There is a two scientists, one is Pauli exclusion principle, that's why the name called as Pauli has given two principle. First is no two electron in an atom can have same set of a 4 quantum number, and two electron sharing one by one, after that filling in opposite spin. The electron are filling in opposite spin. First of all, electron filling one by one, after that it is filling in an opposite spin, like this way, 1 1 1. After that next spin is in anti-clockwise, we can say, this way. However, there is a some as the bond form is the same number of, that is unpaired electron in an ground state, or we can say after that it is going in excited state, that the vacant orbital, the electron is also going in vacant orbital to go in excited state. That's why the pairing of an electron to an unpaired or promoted to a suitable orbital or vacant orbital. Like if we take an example of HF, in case of HF, the fluorine has an electronic ground state electronic configuration is 1s2 2s2 2p5. In case of a 2p5 and 2s here, after that it is in going in this way to form an bond HF, like this. There is a formation of an one bond from here. If we take an example of a water, in case of a central metal atom is oxygen, there is a 2s and 2p. 2p, in case of a 2p there are a 4 orbital. After that it is in going in attached with hydrogen, it form an sp3 hybridization. Then in case of ammonia there are a, in case of a nitrogen there are a 2s2 2p3, 3 hydrogen is attached here. After that it is going in excited state, there is a one unpaired electron, but in case of a water, two unpaired electron. Next, if we take an example of that methane, in case of a methane there is a formation of tetrahedral geometry. That's why there is an, sorry, 1 second. If we take an example of a methane, there is a formation of a tetrahedral. In case of a methane, the central metal atom is carbon, in which electronic configuration is 2s2 2p2. After that it is in going in excited state, means 2s and 2p has same energy level, means that s electron is transferred to p. Here one electron left, and here all three are 1 1 singly occupancy. That's why hydrogen is attached with every S and P to form an methane type of a structure. That's why the main thing is come, that is the shape. Shape means which type of a shape it is in exist like a tetrahedral, bent shape or pyramidal, but there is a, it does not explain whether it bonding with px, py or pz. That is the orbital, which orbital the electron are filling up, like a px, py and pz. In case of a d, there is a dxy, dyz, dxz, or dx square minus y square and dz square. That's why the next concept come is hybridization. Hybridization, in case of a hybridization, hybridization is the mixing of an orbital in same wave function. Like in case of a methane, if we take, the hybridization is taking place with 2s and all three. 3 means 2px, 2py, 2pz. That's why it forming an s, 1s contribution and 3p contribution to form an sp3 hybrid orbital. That's why the contribution of that 2s and 3p orbital, px, py and pz. That's why the linear combination of all four atomic wave function in form of either it is a conjugative, like the addition of all 2s, 2px, 2py, 2pz, and if there is a one antilobe means there is a wave function in negative sign, 2py and 2pz in negative sign. That's why it form an anti-orbital, or we can say. And but in case of a third orbital, there is a 2py and 2pz in negative sign, negative wave function. That's why the linear combination of that sp3 in third form, it is in negative sign. But in case of a sp3 fourth function, the all the three wave function of a p in the negative lobe, but the 2s is in positive lobe to form an sp3 hybrid orbital. If we take an example, like if 2s and 2py and 2px, the orientation in x direction, orientation in y direction, and in this case orientation in z direction, that forming an hybrid orbital which has same energy level to form an spx hybrid orbital of 4sp3. Means the electron density in this case is oriented toward an one-sided in case of an bonding orbital. That's why the orientation in this case is at 109.5. The bond angle, we can say bond angle is 109.5. That is the normal tetrahedral bond angle. And the s character, or we can say there is an formula of that one. Theta is equal to s divided by s minus 1. If the bond angle we know, then we can calculate the s character in an hybrid orbital. Hybrid orbital means in this case it is sp3 hybrid, and the bond angle in this case is 109.5. That's why the s character in this case is 25%, and p character is s plus p is equal to 1, or we can say 100, total 100. If we know the s character, we can easily calculate the p character. 100 minus p, 100 minus s, sorry, 100 minus s, that is the total p character in an hybrid orbital. sp3 hybrid form a stronger bond than the original atomic orbital. If we take if we hybrid with an ground state electronic configuration, because s has some less energy, but in case of p orbital it has higher energy. That's why the orientation of all the all s and p are different. But if it is hybrid, means the energy level after mixing is in same energy level. Same energy level means spx. SPX means S and P has same energy level as that of a atomic orbital of S and P. That the orientation in this case, the orientation is in hydrogen is attached here, hydrogen is attached here, hydrogen is attached here, hydrogen. That's why the bond angle in this case 109.5, that is the shape is known as tetrahedral shape. But if we take an example of that ammonia, in case of ammonia, the ground state electronic configuration is this way. If this is hybrid, means that electron is transfer here. That's why one unpaired electron left, and its shape is known as pyramidal, like N. There is a one unpaired electron and three hydrogen is attached here. That's why that lone pair of electron is easily donated. That's why it is highly basic as compared to methane, because it has lone pair of electron which is easily donated by nitrogen. That's why it is highly basic. Next, if we take an sp2 hybridization, sp2 hybridization means if we take an example of bf3, in case of a bf3, the central metal atom, that is boron, which has an electronic configuration 2s2 2p2. Here are two electron are filling, and that electron 2s to 2p1, after that it is in going in excited state. Excited state means that s electron is transfer here, means three fluorine that form an bond with boron. That's why it's linear combination of an atomic orbital in this way. Like a first sp2 means three contribution, one is from s and two from p. Two from p means 2s and we can say 2px or 2py. If orientation of a 2px is higher, means s and p are linearly combined with px to form an orbital. If an sp2 second wave function probability is like this way, if s has higher character and px and py also contributed in bonding, that's why the wave function in this way 1 by root 3 function of 2s plus 1 by root 6 2p x function of 2px plus 1 by root 2 function of 2py. And in third case, if we take a contribution of a 2s and 2px and 2py, here is the contribution of all the three orbital, and its structure look like an a trigonal structure. Triangular structure means the bond angle in this case is 120 degree. Here are three fluorine is attached together this way, and the bonding in this case is p or from p orbital. Here is the we can say 2s and 2px and 2py. The orientation is towards at a particular triangular type. That's why its shape is known as triangular structure. If we take an example of sp hybridization, s means one s and one p. There are, in case of a bef2 beryllium, means there are only two electron means in case of a beryllium 2s2 1s2 2s2. After that it is going in excited state, that s electron is transferred to vacant p orbital, and that's why the orientation of a 2s is in linear combination, but 2px, either 2px is combined with s, that forming an sp hybrid atomic orbital having an linear shape. Linear shape means it is in a particular linear shape. Linear shape having an bond angle is 180 degree Celsius, 180 degree. And here is the linear combination of an atomic wave function. Like in this case, there is a sp hybridization, means the contribution of s as well as 2px. 2px means half contribution if it is going in bonding orbital. If it is going in anti-bonding, means there is a contribution of s and 2px in negative sign. That's why the every orbital has some geometry and some bond angle. If we take an example of sp3, there is a formation of tetrahedral geometry and the bond angle in this case is 109.5. But if we take an example of sp2, there is a geometry is trigonal and the bond angle in this case is 120 degrees Celsius. And if we take an example of sp hybridi like a BEF2, the shape in this case is linear or the bond angle in this case is 180 degrees Celsius. And next is if d orbital is participating in bonding, means there is a probability that the shape in this case is trigonal bipyramidal and the bond angle in this case are two type. One is axial bond angle and second is equatorial bond angle. In case of axial, the bond angle, like if we take an example of sp3d like a pcl5. In case of a pcl5, central metal atom phosphorus has an electronic configuration 1s2 2s2 2p 2p6 3s2 and 3p 3p3 and 3d 0. Here the p orbital electron transferred to d orbital. That's why d orbital participating in bonding, and for the geometry form found is sp3d. That's why trigonal bipyramidal. Trigonal bipyramidal means there is a formation of an phosphorus. Two type of a bonding is there. One is from axial side and second is from equatorial, like this way. This is equatorial and this is axial. That's why the axial bond angle in this case having a bond angle is 90 degree, but in this equatorial is 120 degree. But if the only dsp2 hybrid orbital, that's the there is a formation of different geometry, that is square planar, and the involvement of an orbital in an electron in effective. That's why it form an bonding orbital which has different bond angle and different geometry. Next is there is a formation of an sorry, one second. There are different molecule which has different hybridization and having a contribution of s. S means the contribution of s orbital, and there is a different bond energy. Bond energy can be calculated from an bond length, and bond length can be calculated from bond angle. If bond angle we know the s character. There is a scenario between the s character and theta. Theta is the bond angle s over s minus 1, and this is the relationship between the s character and bond angle. If we know the bond angle, we can easily calculate the bond length. Bond length means bond length That's why we can easily calculate the bond energy. Bond energy means how much bond energy needed to break that bond. In case of we can say sp hybridide, the formation of an s character is 50 50 50 means 50 s character, 50 p character, and the bond energy in this case is 500 kilojoule per mole, and the bond length is 106.1 picometer. But if we take an example of sp2 hybrid, means the percentage of s character is 1 by third. 1 by third means 33%. 33% means the bond energy in this case is 400 kilojoule per mole, and the bond length in this case is 108.6 picometer. But if we take an example of a methane, there is a hybridization is sp3 hybridization, having an percentage of s character is 25%, and the bond energy in this case is 410, and the bond length is 109.3 picometer. And if we take an example of a radical, radical means only p vacant orbital. Here is a percentage of s character is 0, and the bond energy in this case is 33 kilojoule per mole, and the bond length is 112 picometer. Then we can conclude that if more s character means more overlapping means the mixing of s and p orbital is highly good. If we take the relationship between the hybrid orbital, means the overlapping is maximum in case of sp, after that sp2, and then sp3, and then p orbital. Next concept is participation of an d orbital. Participation of a d orbital means in a bonding. If we take an example of PCl5, here are phosphorus is central metal atom, and the electronic configuration, ground state electronic configuration is 3s2, 3p3, and 3d0. Here are 3 electron in p orbital and 2 electron in s orbital. After that it is going in excited state. Excited state means all s, p and d has equal energy. Equal energy means that s is transferred to p and that p is transferred to d. Here are only s contribution is 1 and 3 p contributed and 1 d contributed. That's why the structure in this case is trigonal bipyramidal. Trigonal bipyramidal means it is an effective mixing. That's why there are two type of a bond. One is axial. These are the axial bond, and these are the equatorial bond. Equatorial bond, and these are the axial bond. That's why the d orbital is participating in mixing, because the it has vacant d orbital, and if chlorine is highly electronegativity, that's why it contract the size. It contract the size of an d orbital. That's why d orbital is participating in bonding. And the bond energy is the d orbital energy is comparable with sp hybrid orbital. The electron negativity of a chlorine make the phosphorus contract the size of an d orbital. That's why it participating in bonding. More contract the size of a d orbital, it is a big in size. This allow 3s 3p 3d orbital to closer to the d orbital. That's why in case of a PCl5, d orbital is participating in bonding. Next, if we take an example of a SF6, in case of SF6, fluorine is electronegativity. Fluorine has higher electronegativity as compared to sulfur. Here is central metal atom is sulfur, having an electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p, 3p, 3 and 3p, we can say here is 3p6. 6 means total s, after that it is going in excited state, means that s orbital is transferred here and that s also transfer in d orbital. D orbital means that contract the size of an d orbital, means sp and d orbital has same energy, that's why it participating in bonding and forming a shape of a sp3d2, means the participation of only one s and 3p and 2 d orbital. That's why its geometry is an octahedral having an hybridization is sp3d2. And the next factor affect the d orbital is the number of a d orbital occupied by the electron. If d orbital has only one electron, the means its radical distance is 1.6 angstrom. If two electron participating, then it's reduce the size in 1.4 angstrom. So d orbital participating in bonding means it contract the size of a d orbital, because if two electron participating means the bond length is less as compared to one electron. 1.4, here is 1.6, that's why it contract the size. Then we can take an example of a CO2. In case of a CO2, carbon is the central metal atom having an electronic configuration is 2s2, 2p, 2p2, and after that it is going in excited state, the s electron is transfer here and here is a contribution of 1s and 3p. 3p means oxygen is attached here, either attached here, that and forming an 2 sigma and 2 pi bond. 2 sigma and 2, because oxygen has a tendency to form an pi bond. That's why 1 sigma and 2 pi. Pi bond do not alter the shape, because pi bonding has a two type. First is sidewise overlapping. Sidewise overlapping, here is head to head overlapping. Head to head overlapping and side to side overlapping. Overlapping are two type. One is from head to head, second is from end to end. So sidewise we can say this is the head to head. This is sidewise or end overlapping, or this is head to head. That's why in this case sp hybridized having an shape is linear, having a bond angle is 180 degree, and in this case the hybridization is sp2. sp2 means the contribution of oxygen is in pi bonding, having an two participation of a two electron. That's why total is 4 electron. 4 electron means the total sp2 hybrid. That's why it forming an bond angle degree and shape is linear. Next is, but if that oxygen, all the next is, sorry, the next is that vacant pz orbital is vacant. That's why it has a chances to forming an another bond. That's why it does not explain the exact geometry of an pi bonding orbital. VBT does not explain these pi bonding exactly. Next, if we take an example of SO2, second pi bonding orbital. Second pi bonding orbital in case of a SO2 central metal atom is sulfur. Here the electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p, 3p4 and 3d0. After that it is going in excited state, means that s orbital is exactly same, but p orbital is transfer here to p to d, means that that is in one lone pair. Here is one lone pair. After that p3d. P3d means one lone pair is here and it forming an 2 sigma bond, one from here, one from here, and 2 pi bond means one from here, one from here. 2 sigma, 2 pi. 2 sigma, 2 pi means that type of a planar trigonal geometry. Here is one lone pair and two bond pair. One bond pair from here, one bond pair from here. This is pi bond. This is also pi bond. In case of a pi bond, one sigma bond is also there. One sigma, one sigma. Total two sigma, two pi. And the shape is V shape or geometry is planar. There are a two term. One is geometry, one second is shape. Geometry and shape, there are a big difference. In case of a shape, it is actual look like, but in case of a geometry, it after hybridization it look like an. There are a two term. One is geometry, second is shape. Shape geometry is like in hybridization. Hybridization. After hybridization, it look like in which shape, in which category, like it is sp3 or sp2 sp, like in this way we can categorize the geometry, like it is linear, trigonal bipyramidal, or tetrahedral, or trigonal planar. But in case of a shape, after participation of all bonding and non-bonding and lone pair of electron, lone pair of electron, it look like this way. In this case, if we take an example, in this case it is planar trigonal, that is the geometry, but its actual shape is V shape, because after participation of an lone pair in the and oxygen, it look like an V shape, like it this way. This is the V shape. Here is the bonding, two bonding and one lone pair of electron. Here is the sulfur atom. Next is, if we take an example of SO3, SO3, in case of SO3, sulfur is the central metal atom, and the central metal atom, there is a formation of an oxygen. Oxygen has a tendency to make a pi bond, and pi bond is formed like in case of a sulfur 2s 1s2 2s2 2p6 3s2 3p 3p4. 3p4 means that one p orbital is transfer here, s orbital is transfer here, to form a bonding of sp2 hybrid orbital. Sp2 hybrid orbital in which participation of an oxygen in an pi bond. Pi bond means the shape is an planar or trigonal. But problem arises in this case is atomic, it involve in pi overlapping because the participation of a d orbital is there, but in hybridization it is in sp2, no d orbital in participating. That's why there is some contradiction between these hybridization and the pi orbital. That's why next theory come role play into come, that is the MOT, molecular orbital theory. Next, that's why there is some drawback of VBT, and this drawback is we can see it does not explain the magnetic behavior, whether it is a paramagnetic or a diamagnetic or ferromagnetic. This type of a behavior cannot be explained by VBT, and there is a formation of an sigma and pi bond. It does not explain easily, or we can there is some contradiction between the pi orbital and d orbital. That's why it does not explain. Next is the color in coordination complex. It does not explain the color of an complex. It does not explain the exact geometry and coordination number. If we take an example of a transient metal complex like a copper ammoniated complex. Here is the central metal atom is copper, in which the participation of a d orbital and 4s empty and p is also empty. If d orbital is participating in here and here, there is an contradiction because d orbital does not participating in bonding. It does not explain the exact geometry, whether it is a tetrahedral or square planar. In this case, it is a tetrahedron, but d orbital is participating. That's why its actual geometry is square planar. That's why it does not explain the exact geometry of an coordination complex. It does not. It does not explain the hybridization of an had homonuclear complex. Homonuclear complex like a, if we take an example of a Cl2 or H2, it cannot be explained by this theory. Also, because in case of a VBT, there is a formation of an resonatic structure. If we take an example of an O3, ozone. Ozone means oxygen that forming a pi bond with next oxygen and coordination bond with next oxygen. That it does not explain by this theory. Any doubt? In next class, we will start with MOT. If any doubt, please write in chat box. The value of a wave function is based upon which type of a bonding is participating. If S contribution is higher, then the contribution of S is taken as higher. If p orbital has contribution is less, then the contribution of a p is taken in negative sign. I will share these slide to you after completion of this unit. Any doubt? Please write in chat box. If any doubt, please write in chat box. Sir, how is check that bonding is pi or d pi? It depend upon surrounding metal, surrounding atom. If we take an example of PCl5, chlorine has a tendency to make only single bond, because chlorine has a tendency to participating with only one electron. But if we take an example of an CO2, there are surrounding metal atom is oxygen. Oxygen has necessity to take two electron means pi bond, but only single electron there is a formation of a sigma bond. It depend upon surrounding atom. In case of a HF, only fluorine has a tendency to take only one electron. But if we take an example of a ozone O3, secondary atom is oxygen, which has a necessity to take two electron. That's why it forming a pi bond. I will share these note to you after completion of this unit. Any doubt? And in next class we will discuss about MOT. Okay. If any doubt, please write in chat box. Okay, thank you. Thank you so much.